guys, your video tonight is talking about perfect cubes. Now, you've heard the term perfect square and you found the square roots of numbers multiple times throughout this year already. But what we haven't talked about is perfect cubes. So let's look at how they're different, perfect squares and perfect cubes, and then we'll focus on finding the cube roots of different numbers. So it's easier to understand these two concepts if you bring it to real world and think about two-dimensional and three-dimensional shapes. So perfect squares being two-dimensional squares. And so let's look, I like to relate it to area. So the area of a square is length times width. Well, since it's a square and it has equal side lengths, the lengths and the widths are the same number. So when you square the same number, you get that resulting perfect square. So here is a square made of 9 units because when we do 3 as the length, 3 is the width, and multiply it, we get that perfect square of 9. If you did 4 times 4, or 4 squared, you get the perfect square of 16. So when you look at perfect squares, think of the area of a square, with both the side lengths being that number that you're multiplying by itself. So now let's bring it to three-dimensional. So instead of area, we're going to bring depth into the picture. And for perfect cubes, think about the volume of a cube, or how many units make up that volume. And it's length times width, which is perfect square, but also times height, and that's where we get that dimension there. So a perfect cube is what results when you cube a number. So multiply that number by itself 3 times. So instead of just doing 3 times 3 and getting the square, we're going to multiply it by 3 again, and we're actually going to get that cube. So 27 would be the perfect cube that results from 3 times 3 times 3. So that's the difference between perfect squares and perfect cubes. Perfect squares are resulted when you square an integer, and perfect cube is when you cube an integer. All right, so let's look at your notes and look at finding the perfect cubes, finding what numbers those are, and then what happens when we take the cube root of them. All right. So your notes for your notebook are orange, and we're just going to kind of create a basic list of the first couple perfect cubes and what their cube roots are, which they're going to be those inverses of each other. So I'll do the first couple, then pause the video, complete the chart, play the video, make sure you filled it in correctly. All right, so let's discover our perfect cubes first. So those are the numbers that result when we cube integers, or multiply an integer by itself 3 times. So the easiest perfect cube, same as the perfect square, 1 times 1 times 1 is 1. So if we want to reverse it and get the cube root of 1, in other words, what integer times itself 3 times gets us 1? That's 1. All right, 2 times 2 is 4, and 4 times 2 is 8. In other words, 2 times 2 times 2 is 8, or 2 cubed. All right, and the opposite of that, or doing the inverse, taking the cube root of 8, would bring us back down to 2, because what number multiplied by itself 3 times give us 8? That would be 2. All right, I'm going to do one more with you. 3 times 3 is 9, times 3 is 27. So the cube root of 27 is 3. All right, pause the video, complete this chart, go all the way to 10, play the video, make sure you got them correct, and then keep going for the practice problems. All right, check and see if you got these correct. So 4 cubed is 64, so the cube root of 64 is 4. 5 cubed is 125, the cube root of 125 is 5. 6 cubed is 216, cube root of 216 is 6. 7 cubed is 343, the cube root of 343 is 7. 8 cubed, 512, the cube root of 512 is 8. 9 cubed is 729. 729, the cube root of that is 9. And lastly, 10 cubed is 1,000. The cube root of 1,000 is 10. Now, by no means do you need to have these cube roots and perfect cubes memorized. You can use your calculator, which we'll talk about at the end of the video. But I definitely would, if I were you, be able to identify the first couple, like 125, 216, the very basic perfect cubes. All right, let's do some examples. So this is how to take the cube root of a fraction. You do the same thing as when you're taking the square root of a fraction. You can separate the numerator and denominator, give them their separate radicals, and solve separately. It's a lot easier. So rewrite the numerator and denominator with separate radical signs. So the cube root of 1 over 27 is the same thing as the cube root of 1 over the cube root of 27. And if you use your chart, the cube root of 1 is 1, and the cube root of 27 is 3. So the cube root of 1 over 27 is the same as 1/3. And right to the side of it, if you want to check, if you cube 1/3, you should get 1 over 27. So 1 times 1 times 1 is 1. 3 times 3 times 3 is 27. So that means we did that correct. Because what number times itself 3 times gives us 1 over 27? That would be 1/3. All right, just 2 practice problems. Let's try one more fraction. So the cube root of 125 over 216 is the same thing as the cube root of 125 over the cube root of 216. The cube root of 125 is 5, and the cube root of 216 is 6, so the cube root of this fraction would be 5/6. Now, last little example, I just kind of want to show you something for exposure, just in case you run into it. You saw that square roots can have 2 solutions, because a negative times a negative can equal that positive. So for example, the square root of 25 is not only 5, because 5 squared is 25, but it's also negative 5, because negative 5 times negative 5 is 25. So cube roots do not have negative solutions, because 3 negatives don't make a positive. However, if you see a negative under that cube root symbol, just understand you're probably multiplying some negative by itself 3 times. So if I want to get negative 27, the cube root of negative 27, I want to know what squared gives me negative 27. I know it's a negative, because it must have 3 negatives to end in a negative. And thinking about 27, that integer would be 3. So the cube root of negative 27 will be negative 3. Again, I don't expect you to see that too much, but just in case you do, this example is there for you. Last thing in the video, I want you to know how to type in the cube root symbol into your calculator, so make sure to write it at the top of your note page somewhere. Maybe highlight it or circle it. So in order to get that cube root symbol in your calculator, remember square root is just a blank radical. It doesn't have any number to the top left. It's understood there's a 2 there. So if you want a cube root, which has the little 3 at the top, you're going to click the math button on your calculator, and then you're going to hit the 4th option, and it'll pop up a cube root symbol with a little box for you to insert what you want. And so, for example, if you typed in the cube root of 27, your calculator would tell you 3. All right. So that concludes your video. Make sure your notes are complete with the example problems, and make sure somewhere on your notes you have how to type a cube root into your calculator. All right.